negative 2, 8. And the slope is undefined. What types of lines have undefined slopes? Vertical. Vertical. All vertical lines look the same if you took them off their location. Vertical lines go up and down. What form do equations for vertical lines have? What form are they in? No, not slope intercept. Not that. Are they? What do they look like? What do the equations for vertical lines look like? X equals a number. All vertical lines have equations that are x equals a number. So it doesn't matter what y is. So the only thing that matters is the x value. So it's going to be x equals what? What's the only point we know on this vertical line, Milo? What's the only point we know on this vertical line? That 8 is not a point. A point has two numbers. Which point is the only one we know? What? Yes, exactly. So we know that negative 2, 8 is on this. Give me another point that's definitely on this vertical line. What could that point be? It's a vertical line, so what stays the same? The x-coordinate or the y-coordinate? We move that point up. So did we change the x value or the y value? No. The y value, that's right. So give me any other point that's on that vertical line. No, the x value stayed the same, Milo. So give me any other point. What? 6 is not, Milo, 6 is not a point. You have to give me two numbers. Yep. Sure. Negative 2 is higher than 8, so give me something higher than 8. Negative 2, 9. Give me another point that's between the two. Negative 2, what? Exactly. So what's the only thing that's changing? So this could be negative 2, 7, for example. What's the only thing that's changing? The y value. The only thing that's changing is the y value. So it doesn't matter what the y value is, so we don't even put the y value in. So it's going to be x equals what is the function, is the equation for this function? X equals negative 2. All vertical lines have the equation x equals a number. What about horizontal lines? Y equals a number. So if we wanted, so here's negative 2, 8 right here. Let's say I wanted a horizontal line. What does that look like? Oh, it looks like this. What would the equation for this one be? Correct. Y equals 8 if it was horizontal. Correct. Good job. Good job. You write that in. What is slope-intercept form? What's the general form for slope-intercept? Y equals mx plus b. So we have to isolate what? Y. What's the first thing we would do, Aubrey, if we wanted to isolate y on that equation right there? Guys, you can just chill for 1 sec. What? I can't hear you.
It's already isolated.
No, it's not. 4 is in front of it. 3x is also in front of it.
Oh, I was looking at the y.
Oh! I was like, no, I don't think so. Nope, it's already multiplied by 4. How do you what's before that? Yes, you could divide by 4, but what's something? There you go. Woo. We like to divide. Could we divide by 4 first if we wanted to? If we divided by 4, we would have to divide what by 4? Everything. Everything by 4. So if we divided by 4, you could do that. You have to divide everything. You get 3/4 x plus, what does that become? Y equals. Now what could we do if we want to isolate y?
Subtract 3/4.
3/4 what?
X.
Correct. So what would you subtract?
Minus 3/4 x.
Correct. You can't just subtract 3/4. You have to subtract 3/4 x. So you end up with y is equal to negative 3/4 x plus 3. Why is it useful to have it in slope-intercept form?
Because then you can just see what your y-intercept and your slope is.
Yeah, they're right there in front of you. So this right here, what is that? That's the slope. And what's this?
Y-intercept.
Y-intercept. Exactly.
I just have a question.
Yeah.
Tell you to do this.
With this section, you're going to really just do 3 things. You're going to draw, then you're going to test, and then you're going to shade. You're going to draw, test, and shade. What you're going to draw is something you've had some practice drawing before. You're going to draw lines. You're going to test points, and then you're going to shade a side. But those 3 words are really the key. You're going to draw, you're going to test, and you're going to shade. The linear inequalities we're going to look like, the ones we're going to look at, all of them really look like, ax plus by is less than c, ax plus by is less than or equal to c, or ax plus by is greater than c, or ax plus by is greater than or equal to c. We're specifically looking at linear inequalities in two variables, and only two variables. The idea here is you're going to graph a line. The line is going to be solid or dotted. When do you think it's going to be solid, and when do you think it's going to be dotted? Good guess. The greater than or less than is going to affect which side you shade. The equal to, the greater than or less than is not going to affect dotted or solid. What do you think is going to affect dotted or solid? Any other guesses? That's right. There's going to be two different things. One side or the other. If it's equal or not. If it's strictly greater than or strictly less than, it's going to be a dotted line. If it's greater than or equal to or less than or equal to, it's going to be a solid line. But you remember, all you need to remember, you're going to draw a line, you're going to test a point, and you're going to shade a side. Shade a side. So what are you going to do? You're going to end up with things that look like this. You're going to end up with things that look like this. You have the black line right here. This represents x plus y equals 5. This is the collection of all points where x plus y equals 5. For example, 0, 5. When x is 0, y is 5. 5, 0 is also on there. When x is 5, y is 0. Can you give me one more point that's on there? What's another point that's on that line?
2, 4.
2 plus 4 is 5?
2, 4. 2, 3.
2, 3. Thank you. So 2 plus 3 is 5. So 2, 3 is there. 1, 5. 5, 1. There's an infinite number of points that live on that line. The pink region represents all of the points, x and y, where x and y is less than 5. The blue points represent all the points that make this true, x plus y is greater than 5. Greater than 5, less than 5 when you add them together. How many points are here? Well, there's a lot of them. How many points are here? A lot of them. A lot of them, an infinite number. So, what kind of question could we do? Well, just remember, you're going to draw, you're going to test, and you're going to shade. So those are your 3 points. So what kind of example could you have? You could have this right here. The first step is going to be, what was that first word? Harrison, could you shut the door? What was that first word? Draw. And remember, what are we going to draw? We're going to draw the line. So if I gave you this inequality, what are you going to draw? You're going to draw the graph of what function? That isn't a function, that's an inequality. What function are you going to draw? Instead of an inequality, all you need to do is replace the inequality with a, say it, what'd you say? An equal sign. So graph this for me. 3x plus 2y is equal to 6. Graph that for me, which is the same thing. Draw that line for me. Did you go about graphing this? What did you do first? Yep, what'd you do with it? Sure, so you subtracted 3x maybe, and then you divided by, and that's kind of nice. How many people did this? How many people did that? A bunch of you? Okay, you like that because what does it give you immediately? The slope and the y-intercept. Now, if you do it this way, I would really like it if you started at the y-intercept. So a lot of you, the first thing you did was you drew axes, so you don't need to do that, but you can. In this case, you really only need the first quadrant. And again, my lines aren't that good. You can use the line draw tool and get a lot better than that. So pick 3. There it is. What's that slope mean? You go down 3 and over, down 3 and over 2. So down 3 crosses here at 2. And then once you have this, connect the lines and there you go. That's great. Very good. Now, is there a quicker way or a different way? Did anybody find the intercepts maybe? Yes, Milo.
How do you know what to start on the y? So you always start on the y?
Because that is the y-intercept, yes. It is the y-intercept, so it crosses the y-axis, yes. Did anybody find the intercepts instead? Here's another way to do it. How many points do you need to graph a line? 2. When x is 0, what's y? On this one, when x is 0, what's y? 3. When y is 0, what's x? 2. 2. 3 times 2, right? Hey, look, plot 2 points, connect them. Did we even have to know the slope? No. What form is this line in, by the way? What form is this? This is standard form. If you see standard form, a really great thing to do, find the intercepts. If you're trying to graph a line and it's in standard form, find the intercepts and connect.
And
Okay.
when you find the intercept,
Just connect them, then you're done. You don't even need to. I mean, the thing is, this wasn't that hard, right? I mean, that's okay, but is it possible to make a small mistake?
you would think, yeah.
Absolutely. You divide wrong, you go up 2 and over 3. You know, it's really easy. Connecting dots, is that about as straightforward as it gets? About as straightforward as it gets. Okay, but we're not done graphing this inequality, Nick. First of all, is it going to be a solid or dotted line? What do you think?
Dotted.
It's equal to, so it's going to be
Solid.
solid. It's going to contain the line. So it does contain the line. So we did, if it was dotted, you just have to erase it and make it dotted. But it's strict, it's greater than or equal to, so it's solid. So the next, what was after draw? What was that next word?
Test.
Test. Test a point. Pick any point not on the line. And you're going to be using this point to you're going to be plugging this point in. So you want to pick a point. Could you pick the point 1/5, 6.9854328859? Sure. But why is that not a very good point to pick, Milo? Why do you think?
Pretty hard to graph.
Yeah, hard to graph, hard to plug into things. So you pick a point that's really easy to plug in. What point is the easiest to plug in? Origin. If the line doesn't go through the origin, you can pick it. So can you pick the origin in this case? Yeah, so our point, our test point, literally write this down. I love it when you don't have to do it right now, but when you're doing the work, so right now I guess, our test point is going to be the origin because the line we have does not go through it. Doesn't go through it. What do you do with that test point? You take your inequality. What was it? It was 3 what? 3x plus 2y is greater than or equal to 6. You see if the test point makes the statement true. You test to see if the test point makes the statement true. So does 3 times 0 plus 2 times 0, is that greater than or equal to 6? No. So if 0, 0 doesn't make it true, what side do you think you have to shade? Do you shade this side where the 0, 0 is, or do you shade the other side? Other side. A point either works, all the points on one side work, or all the points don't work. We know we're going to shade one side, so if we know one side doesn't work, which side does work? The other one. If 0, 0 did work, where would we shade? The other side. Yes, Harrison. Is it dotted or solid? Are you shading the right side? Test a point. 0, 0 is a great point. What's the only time you can't use 0, 0? If the line goes through it. If it's on the line. Exactly. When x is 0, what's y going to be? Negative 4/3, yeah. And when, so that is the y-intercept. If y is 0, what's x? What? 4. You have 2 points. What do you do with those 2 points? Plot them. Yep. Okay, I just want to, so someone asked, so 0, 4. Where does 0, 4? Sorry, is it 4, 0 or 0, 4? 4, 0, right? So let's just call that right there. Let's call that 4, 0. Okay, kids, if that's 4, 0, where's the next point going to be? It's going to be on the what axis, the x-axis or the y-axis? So it's right about, I'm just going to say, call it right there. Doesn't have to be exact. Negative 4/3, comma, 0. And what do you do with those 2 points? Connect them. Is it going to be dotted or solid? Dotted, because there's no equal sign. So I'm going to make this a dotted line. You got the dotted line there? It's kind of broken. Now, you drew the line. Now you have to test a point. What point do you want to test? The origin again. So we're going to test 0, 0. Is 0 minus 3 times 0, is that question mark less than 4? Is 0 less than 4? Yes. So are we going to shade above or below? Here's 0, 0. Are we shading up there or below there? Up. So when you shade this, it's going to look like this. So you drew the line, you tested a point, and then you shaded.
Wasn't the slope 4?
No, the slope is not 4. You should not have to find the slope. You just need to isolate right here. Did we do something wrong?
I'm just saying, like, how did you draw?
Changes here. What's the only new thing I added in? The and. There's two things here, and. So you're going to graph one of them, and let's do this together. What form is this in right here? It's kind of like a standard form, so what should we find? The intercepts. When x is 0 on this one, how would you do the algebra? You're solving for the intercepts of 2x plus 4y equals 5. So when x is 0, you end up with 4y equals 5. What does y equal, Zoya? What does y equals? 5 over 4. So what's our y-intercept? 0, comma, 5 over 4. But now we also want to find the x-intercepts. That's going to be 2x plus 4 times 0 equals 5. So Nick, what is x going to equal here? If 2x plus 4 times 0 equals 5, what does x equal? So if x is equal to 5 over 2, what does that make the x-intercept? 5 over 2, comma, 0. You have 2 points, so now what do you do? You have 2 points, so what do you do with them? You graph the 2 points. So here's 5/4. There's 5/4. 5 over 2. Oh, wait, no, 5 over 2, excuse me. Thank you. Yep, that's correct. So let's say 2.5. There's 5 over 2. And here's, I don't know, 5/4. Are you going to connect it with a dotted or solid line chain? Dotted or solid line? Solid, exactly. So let's change colors a little bit. Let's make it blue. So we have a solid line. And then what's that last word? We drew it. Now we have to, what's the next word? Draw, then what? Before shading. We don't know what to shade it. We have to test. What point should we test? What's the easy point to test? No. We just tested the same point twice. What was that same point we just tested in the last example? Look up here. What point did we test here? What point did we test there? 0, 0. Unless the line passes through it. Can we test 0, 0 in this case? Plug in 0 here. Is 0 greater than 5? Look, does this pass through? Does this line pass through the origin? What? We're not there yet. We're not doing that yet. We're just doing this. Just focus on this. Is 0 greater than 5? No. So which side do we shade? Do we shade above or below? Here's 0, 0. This did not work. So we shade above. So shade lightly. So we'll shade lightly above. Here we're shading. Now, what else do we have to graph on this? X is greater than or equal to 1. We have to graph that. X equals 1. Is that horizontal or vertical, Alex? X equals 1. Is that horizontal or vertical? No. X equals 1. So give me 1 point that is. Where does x equal 1? Right about here. Here's 1. What's another point where x equals 1? Give me any point where x equals 1. 1, 1. What's another one? 1, 2. 1, 3. 1, 4. Is that going up or down? It's going up. Could you go down? Yeah, 1, negative 1. 1, negative 2. X equals is vertical. Y equals is. So what kind of line is this? Vertical. So let's draw this. It just goes straight up and. Oh, do I keep it solid or do I make it dotted? Keep it solid. Now, what point do I test? What point do I test? Origin! Always answer origin unless the line goes through the origin. So in this case, is 0 greater than 1? No. So do I shade the left or right of this line? The right-hand side. So let's shade to the right here. Now the question is, where are those both true? Where do those regions overlap? Could you shade that for me? And I'll do a different color. This is too dark here. Let's do a slightly less dark color for this shading. We shade to the right, let's say with yellow here. So here we are, right here. So where do they overlap? I'll overlap them in purple. They overlap right. Oh, gotta get the purple. Right. Oh, can't get it. Here, this is where they overlap. You see that overlap right there?
Don't you need the little part right there? The other little part?
Nope. Look, where is it yellow and blue? it's blue here, right? And it's yellow to the right. Is it blue right here?
No, I thought
Oh, where?
below.
Down here?
No.
Oh, over here. Oh, it didn't extend below. I see what you're saying. I'm sorry. It's fun. It's like that thing, that one. No, no. That's absolutely correct. It does keep on extending this way. You're absolutely correct. There it is. But does it contain this little corner piece right here? No. The blue is above. This is to the yellow goes to the right. So it's going to go all the way here. There it is. Now, when you're shading, don't go totally berserk. Okay? I see some people shade dark and then darker and then they like burn through the paper. Okay? Do it lightly, and then shade your final image. Take your time. Do this neatly. Take your time. Do this neatly, please. The or, so this is union, right? So instead of overlapping, what are we looking for? It's not where they overlap is what we're looking for. What are we looking for? All of it. All of it. So now if we're looking for the union, what else do we have to shade in purple? Everything else that is included here. So it's here and here. It's everything that covers. This is the union of the two things. The union. Where do the points either are in one or both sets? Is this point in either set? No. This one? No. Blue and yellow. It's just putting everything. Or is going to be everything. We looked at these in sets, like two sets of numbers, and you put them together. All of them put together. That's the union. But what's the intersection, the and? Just what they share. So that right there, you can go even more shading happy. Even more shading happy. After this, intercepts, right? Intercepts. Oh, yeah. 0, 4, and 5, 0. And this one is 0, 3, and -2, 0. When you graph these, what is it going to look like? Well, you have 0, 4, and you have 5, 0 here. Is it solid or dotted?
Dotted.
Equal to. So what is it?
Oh, that's solid.
Solid. So once you draw 1, please shade. Plug in 0. Is 0 plus 0 less than 20, Milo? What? Yes, it is. So do we shade this above or below? 0 is below, and it's true, so do we shade above or below? Below. So let's use a light one there and be really nice about this. So we know it's going to go down like this.
Use yellow and blue all the time.
I'll try. Okay, I will.
No, because it turns green.
Oh, nice. I like that. Okay, so then 0, 3 is right here, and -2, 0, let's say, is right there. What do we do with those 2 points? Connect them, yay! What point do we test? 0. Is 0 minus 0 greater than 6?
No.
No, so do we shade above or below the blue line? Above. So if we do this, we shade above this thing. Now, where do they intersect? They intersect right here. There's the intersection right there. Yay! Exciting. Woo! Exciting about it. Very good job, Nick. So if I go back here, let's go back to the eraser here. I don't want to do that kind of eraser. What was it? Draw. There's a different type right here. This little medium eraser here. Which one needs to be dotted? The blue line or the red line? The blue line. So you go doot, 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 like this. Watch, you go this. Look what I'm doing here. You go to the draw and then the eraser. You can choose small, medium, large, or stroke is when it deletes all. So there you go, dotted. Excellent. That was very good. Good job. Something here. Everybody, hands up. Hands up, everybody. Hands up. Hands up. There you go. What's this called? AX plus BY equals C. What is that? Standard form. What about this? Y equals MX plus B. Slope what? Intercept. And y minus y1 is equal to m times x minus x1. What is that? Point slope. So these are all good in specific cases. If you have the slope and the intercept, which one should you use? Yeah. If you have point and any, if you have slope at any point, which one should you use? Point slope. When you have standard form, what can you find really easily when it's written? You can find intercepts really easily. You can find them easily. Now, one point of clarification, which is important, depending on the book, sometimes standard form is defined differently. I didn't care if A, B, or C was a fraction. Sometimes books do. So just be prepared. Sometimes you might see this happen. You might see, technically, is this in standard form? Technically? Yeah. Sometimes, though, people don't like to have fractions in the standard form. X goes first, then Y, then the constant. What could you multiply everything by to get rid of that fraction? You could turn this into X plus what Y? Equals. These are the same. Some people really like the bottom one over the top. Sometimes. It's just a little easier to write down. Just recognize that. You need to know these three forms.